Hello, everybody. I wanted to spend a little bit of time talking about how to find the intersection points of two polynomials. We're going to do it graphically, which is a really short thing. And then, more importantly, I want to show you how to do it algebraically, because I know that's a little trickier. Okay? So, if you want to find the intersection points graphically, you graph both of the polynomials, and then you look, and you try to find the places where they're crossing. So, there are two intersection points for these polynomials at -6, 0 and 4, 10. Now you might ask, why do the polynomials cross over at those specific points? And the reason would be if I plug in the x value, that is, if I put in 4 into either function, I will get the same output, which is 10. Believe me? You don't have to believe me. We can see. So let's try it. For my bottom function, if I replace x with 4, I'd have 4 plus 6, which is obviously 10. So that function contains the 4.4 comma 10. And if I do the same thing with the other function, the parabola, if I put in 4 in for the x, well, I'd have 4 plus 6 in the first parenthesis and 4 minus 3 in the second parenthesis. And if we simplify that, I would be 10 times 1, which, you guessed it, is still 10, which tells me that 4 comma 10 is also a point on the second function. So for the same value of x, they have the same output, the same y value. And this would also work with the point -6, 0. I'm not going to do that for time's sake, but that's what you're finding when you find the intersection points. Finding the intersections is also sometimes called solving the system of equations. Oh, okay. Now, more importantly, I want to show you how to do that with algebra, because that's a skill that we want you to have. So here's what I'm going to do. I'm going to think to myself, all right, well, I've got these two functions. I'm going to write them out here. X plus 6 times x minus 3. And I want to know, where does it intersect with just x plus 6? That was the other function all by itself. Now, if I want to know where they intersect, I'm essentially thinking to myself, where are they equal to each other? Okay, so I'm setting them equal to each other, and then if I solve this, if I get x by itself, I will be finding the x coordinates for the intersection points. And I already know what they're going to be because we just saw them on the graph. But let's suspend our disbelief for a minute and say we're starting from scratch. Okay, so how do I solve this? How do I get the x values algebraically? Well, I'm going to do a little thing here that's going to seem kind of weird at first, but I'm going to put a 1 in front of the x plus 6, because there's one of them, and because these problems are a little bit of a setup, that's going to help us out a lot later on. Okay, just take my word for it. Multiplying by 1 doesn't change anything, so it's not hurting anything to put a 1 out in front. Now, here's what I'm going to do. I know that at the end of the day, I want to end up with something like this. I want two factors, or I guess it could be more than 2, but it's going to be 2. Two factors multiplied together equal to 0. Because if I have that, then I can use the zero product property, and that will let me solve for x, right? That's what we've been doing a lot lately with polynomials, right? Getting the x-intercepts is using the zero product property, okay? So anyway, how am I going to get there? Well, I need 0 on one side, don't I? So I'm going to cancel out everything I have over here. And to cancel out 1 times x plus 6, I'm going to subtract away 1 times x plus 6 from that side. And that would leave me with 0. But of course, the equation would not be balanced, okay? It's not equal unless you do the same thing to both sides, right? So if I subtract 1 times x plus 6 from over here, I am also going to subtract 1 times x plus 6 from this side. It would be very tempting to just cancel out those x plus 6's, but that's not the way this works, okay? Because right now, there's technically multiplication going on right there. And you can't add or subtract until all of your multiplication is done, right? That's how order of operations goes. So I can't take that away. Okay, what I can do is write the two terms out side by side. It's going to look funny, but I'm going to do it anyway. Here I go. X plus 6 times x minus 3. And then I'll have the minus 1 times x plus 6 over here. Now, having accomplished that, here's where it gets extra wacky. So, what I notice is that both of these terms, and when I say terms, that there's two of them here, right? A term is, when you've got stuff separated by a negative sign. Okay? These two terms have a common factor of x plus 6. They both have that. So what I'm going to do, if you have two numbers and they're both being multiplied by the same thing, you can factor it out, which is like taking that number and pulling it to the outside. Normally the outside is over here. Pulling it to the outside, you're dividing it away from both of those terms, okay? And so here's what that'll look like. I'll take x plus 6 and I'll put it on the outside here. And then I'll ask myself, well, if I divided x plus 6 out of both of those things, well then what would be left? What would be left from those two terms? Well, what's left over? Well, this still has the x minus 3. And this would still have the negative 1. So that's what's going to be left over after I do my factoring. And this is really close to what I wanted because I can see now that I've got x plus 6 in here. And if I simplify what's inside of those parentheses, I would have x minus 4. And this allows me to use the zero product property. I ask myself, okay, if two things are multiplied together equal to 0, what makes them equal 0? Well, obviously, if x equals negative 6, then the first group will be equal to 0. And if x equals positive 4, then the second group will be equal to 0. And those are my x values for my coordinate points, which we already knew. We already knew that they were going to intersect at 4 something and negative 6 something. Okay? But I'm finding intersection points, which implies that I have a y value as well. So now I need to go back and I need to find the y value for each of those equations. So if I was starting fresh, I would probably just choose the simpler equation, x plus 6, and I would insert the numbers into that equation. Now, you already saw me do this at the beginning if you watched the beginning, but if I replace x with 4, I get 10. And we saw at the beginning that whichever equation you choose, you should get the same output if these are the intersection points. Okay? And the other one was 0. So yeah, there's an example, and that might be cool.